All right, welcome back to lesson two, where we're going to spend some time talking about playing with probability. Today, we'll be learning to describe in writing the sample space for chance experiments, so I can use that sample space to calculate the probability of compound events. All right, our sample space, if you defined it last lesson, is the set of all outcomes regarding a particular event. I'll know I've got it when I can find the sample space for chance experiments, model situations using probability, and use sample space to calculate probability. Let's begin. So our first activity actually has you heading towards a activity wheel that I don't think is being shared in this video. No, so I'm not allowed to switch between tabs. So anyway, you're going to use that wheel. So make sure you click that hyperlink and you'll spin the wheel. Make sure that you do not delete any names after a name is presented. Okay, just respin the wheel. You're going to repeat that process 15 times, and you're going to type all those names into this box, right? So you might have Elena, you might have Han, Andre, Diego, Diego, right? Let's say Diego wins a few times. You might have, I don't know, Sally, so on and so forth, right? In our right text box, which name did you draw the most frequently? What was the relative frequency of the name you drew most frequently? So in case you've forgotten, relative frequency is nothing more than a probability, right? So let's say here, right, we had 1, 2, 3, 4, 5, 6, 7 names, right? The relative frequency for Diego would be 3 out of 7. It would translate to some numerical decimal value. Estimate the probability of drawing the name you drew most frequently. Your student winners will conveniently be located here after you type them in. That way you don't have to go back and forth. But based on the data that you collected in the warm-up, answer the following questions. What is the probability of drawing each of these names from the wheel? Diego, Mai, Priya, Elena, Andre, Noah, and Jada. Okay, based on your data, so out of 15 names. The next month, the wheel contains 15 names as well. Mai's name is included 5 times, Elena's 4, Andre's 3, Diego's name 2 times, and Jada's name 1 time. The teacher draws names one at a time, replacing them each time. What might the teacher's list of names drawn look like if she draws 10 times? Is this the only list of names drawn that is possible? And explain your reasoning below. Okay. As I said before, this unit is going to require you to think much more critically than you may have in the past. All right, so for our next activity, you'll be tasked with thinking through words that have probabilities given when selecting a letter at random from the word. But before we get there, let's talk a little bit about what probability actually is. Okay, so the P obviously stands for probability. So the probability of an event is the number of, actually, let's change this to number of favorable outcomes for an event divided by the number of total outcomes. And how I always kind of remind myself of this concept is in flipping a coin, the probability of heads. There is only one favorable outcome for acquiring a heads when flipping a coin. However, there are 2 total outcomes, heads and tails, when flipping that coin. And that is kind of my rhyme and rhythm for probability. So that brings us back to here, where you'll be determining words that fulfill this particular set of probabilities. So I'll help you with part A. Part A says the probability of having a vowel is 1/3. So total outcomes is 3. So I knew that I need a 3-letter word that has one value and two consonants. If you've forgotten, vowel, it's A-E-I-O-N-U. So one word that I could select is the word cat, because there are two consonants, C and T, and one value, A. So if I were to select a letter at random, there would be a 1/3 probability that I would select A, and a 2/3 probability that I would select a consonant. I could use dog, I could use fun, and the list goes on and on. You do not have to give me 50 million, but I would think of 4 to 5. That way you can kind of get into this rhythm. Each of the whole numbers from 1 to 25 is written on a slip of paper and placed into a bag. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so on and so forth, up to 25. It's your responsibility to calculate each probability of the scenarios described. So we have the probability of the number being prime, the probability of the number being divisible by 3 but not by 2, the probability of it being a multiple of 5, greater than 20, so on and so forth. I would first represent them as a fraction before converting them into a decimal value. So I'll start with the prime numbers. I know that numbers like 1, 3, so that's 2, 5, that's another one, 7, um, 11, 13, 17, 19, 23, right? So that's 9. So there's 9 prime numbers out of 25 in the bag. That would equate to roughly a 36. Oh, that's interesting. So 36, well, let's reduce that first. All right, so a 1/4, which is approximately 36%. I don't want to do the percent symbol here because it keeps typing in of. Right, so you'll replicate that process, but based on the context given here within the parentheses. And then you're going to be tasked with creating 2 of your own probability questions that give a probability of 1/25 as the answer. Okay, so here using the numbers again, and then 2 additional probability questions that give the probability of 3/25 of the answer. So you could start with probability, actually, math button, probability of, and then type your event here, and then probability of, type your second event here. Okay, so think through those. I would probably stay away from things that are like the probability of the number being 6, because that's kind of very straightforward. We spent an entire unit talking about properties of numbers, so I have the utmost confidence in your abilities to create 4 very unique, complex situations. But that'll do it for this lesson. Very simple and straightforward. Lesson 2 summary again. Once again, I would read that conscientiously, maybe notate it a little bit before pausing at the enhancement opportunities.